JProfiler's Kafka probes are packed with features. In the first screencast, I gave a general overview of what the Kafka probes can do. In this screencast, we're taking a close look at some of their advanced features. Do you remember how Kafka messages were named with the topic name? That naming determined hotspots and call tree splittings. In real life, we have semantic information in the Kafka values that we want to see in the hotspots and the event names, like the event type in our production event messages. It can be one of the strings start, stop, or error, chosen at random. For error events, the consumer will take a lot longer to process the event. Let's check how we can add the event type to the message names for hotspots and call tree splitting in JProfiler. By default, only the topic name is used. To use data from the message value, we adjust the Kafka consumer probe configuration. Here you see that the hotspot naming either uses the message topic or a configurable script whose return value is used as the name. Let's switch to the script mode, where I have already prepared a script for extracting the event type string. The script gets a context object and a Kafka record, which gives us access to the topic, value, and more. In the demo application, messages are deserialized as strings, so I'm using Jackson to parse the production events. Since the session class path comes from the IDE, the Jackson Object Mapper class is available out of the box. Creating an object mapper is expensive, so we only do that once and save it in the script context. Once we have our production event, we append the event type to the topic in the square brackets. For other events, we simply return the topic name. Let's use this script. The script has been compiled locally and will be transferred to the profile JVM so that the Kafka probe can use it there. Applying new profiling settings means that the currently recorded data is discarded. Now we see the different event types for the production events with separate call trees. The waiting state of the additional thread sleep call in the error case does not contribute a lot to the runnable thread state, which is the default mode for the call tree. However, in the all states mode, the error event types move to the top because the sleep time is fully counted there. In the probe view, the default thread state is all states, because probes mostly measure high-level operations that involve I/O operations. Here we see that the error production events account for 61% of all message-consuming operations. The same naming is applied to single events, but you can change it to show more data for debugging. Here we only handle sensor data events and append the toString value of their deserialized data object to the topic. For other messages, we just return the name that was constructed for the hotspots by returning the hotspot name parameter. The description column now shows the desired data. For a more detailed inspection, use the Row Details dialog. For the sensor data messages, our demo app provides a trigger API to introduce a temperature spike that will take extra processing time in the consumer. To track that spike, let's first add the sensor data hotspot to the probe tracker. Now we visit the API web page created by the Swagger UI and trigger a message with a temperature higher than 200 degrees. Let's check the probe tracker. The spike in the sensor data processing time is clearly visible. In the events view, we first restrict to sensor data events. Then we can see in the distribution histogram that there is one message whose processing time is far longer than that of all other sensor data events. The description that we constructed in the events naming script now contains information that will help us get to the root of the problem. This is where JProfiler's advanced Kafka probes go beyond call trees and show you exactly what's going on. All this without touching your code.